And now in this lecture we'll find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. All those sides are equal to each other and all the interior angles are equal also to each other. In addition, we also know that line segment PB equals to 3 units in its length. And our mission is to find out the length of side PA that is equal to X. Okay? So first of all, we find out the sum of the angles in any regular hexagon. So I'll draw a regular hexagon that could be any regular hexagon, and we'll find out the sum of the angles in that regular hexagon. So that is a regular hexagon. A, B, C, D, E, F. Okay. In order to find out the sum of this regular hexagon angles, we will join points B and E together by straight line. By joining points B and D, we created there two quadrilaterals, quadrilateral A, B, F, E, this quadrilateral, and quadrilateral B, C, D, E. We know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in this quadrilateral A, B, F, E equals to 360 degrees. And the sum of the angles in quadrilateral B, C, D, E will be also equal to 360 degrees. And the sum of the angles on both quadrilaterals will be equal to 360 degrees plus 360 degrees, that is actually 720 degrees. This will be actually the sum of the angles in this regular hexagon, because of the fact that this regular hexagon consists of two quadrilaterals. Okay, so we found out that the sum of the angles in any regular hexagon is equal to 720 degrees. And because of the fact that all the 6 interior angles of this regular hexagon and any regular hexagon are equal to each other, we get that the sum of the angles in this regular hexagon that is equal to 720 degrees over the number of the angles, that is 6. Every regular hexagon has 6 interior angles. So the total sum of the 6 angles over 6 will give us the size of one angle. Why? Because all the angles are equal to each other in their sizes. So 720 degrees over 6 is 120 degrees. So we actually found out that each angle in any regular hexagon is equal to 120 degrees in its size. So yeah, all those 6 internal angles of this regular hexagon are equal to 120 degrees in their sizes. So this angle equals to 120 degrees. This angle equals to 120 degrees. This angle equals to 120 degrees in its size. This angle is also equal to 120 degrees in its size. This angle equals to 120 degrees, and this angle equals to 120 degrees in its size. And well, as I already mentioned before, a regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. And because of the fact that one side of this regular hexagon it is equal to 2 units in its length, all the other sides of this regular hexagon will be equal to 2 points. Okay. CD, side CD equals to 2 units in its length. Side CB, it is also equals to 2 units in its length. In the next step, we will extend side DC by a straight line. We'll define this point as L. DC is one side out of 6 sides of this regular hexagon, and therefore it is absolutely a straight line. And when you extend a straight line by a straight line, the result must be a straight line. Therefore, DL is a straight line. Okay? You can write down that line segment DL is a straight line. DL is a straight line. And we also have the old rule number 1, that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on this side, or you can say it is the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. Okay, so which angles we have on this side of the straight line DL at point C? We have this angle that is equal to 120 degrees. Plus the missing angle, that is actually angle BCL. This is angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. So we will subtract 120 degrees from this equation, and we'll get that the missing angle, angle BCL, equals to 180 degrees minus 120 degrees, it is 60 degrees. So here, this this missing angle BCL equals to 60 degrees in size. In the next step, from point B, we will draw perpendicular on DL. Okay, from point B, we draw perpendicular on DL. So this angle equals to 90 degrees, and this angle it is also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. So by doing this construction I created here the right triangle CBM. I'll copy the right triangle CBM in a new page and we will analyze it. So this is the right triangle BMC that I copied from the original drawing. Angle BCM equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. Side BC equals to 2 units because of the fact that it is one side of the regular hexagon A, B, C, D, E, F. We know that all its sides are equal to each other. Each side is equal to 2 units. It's given us that AB equals to 2 units, therefore all the other sides must be also equal to 2 units. So in this triangle BCM, the right triangle BCM, we know that cosine 60 degrees equals to CM over BC. Okay, cosine 60 degrees equals to CM over BC or CB. CM is the missing side, so we leave it as it is. And BC equals to 2 units, therefore we substitute BC by 2. And we know that cosine 60 degrees equals to 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM over 2. Here we will multiply both sides of the equation by 2, and we get that CM equals to 1 unit. CM equals to 1 unit. Here in the original drawing, you can also write down that CM equals to 1 unit. Okay. Likewise, we continue to focus on the right triangle CBM. In the right triangle CBM, sinus 60 degrees equals to BM over CB. Okay, sinus 60 degrees equals to BM over the hypotenuse CB. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2. And it is equal to BM. BM is the missing side, so we leave it as it is. BM over CB. CB equals to 2 units, so we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to BM over 2. We multiply this equation by 2, and we get that BM equals to the square root of 3 units. Here BM equals to the square root of 3 units. You can write down in the original drawing that BM equals to the square root of 3 units. In the next step, we'll focus on the right triangle, triangle PMB. On this right triangle, triangle PMB. In this right triangle, 97 cm equals to 1 unit. PC is unknown, so we'll define the length of PC as A. So PC equals to A units according to our definition. And therefore, side PM of the right triangle PMB equals to PC plus CM. PC plus CM equals to PM. PC equals to A, CM equals to 1, therefore PM equals to A plus 1. PM equals to A plus 1. BM equals to the square root of 3 units. And PB equals to 3 units, according to what is given in the question. So I'll copy this right triangle PMB in the new page, and we will implement the Pythagoras theorem on this right triangle PMB. PM equals to A plus 1 units in its length. So this is actually the right triangle PMB to take over from the original drawing. PM equals to A plus 1 units. BM equals to the square root of 3 units. And PB equals to 3 units according to what is given as the question. Okay, the hypotenuse PB equals to 3 units according to what is given as the question. So we'll implement on this right triangle PBM the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle PMB is PB, and therefore the square of the hypotenuse is PB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM squared plus BM squared. So according to the Pythagoras theorem, in the right triangle PMB, PB squared equals to PM squared plus BM squared. PB equals to 3 units, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to A plus 1, therefore PM squared equals to A plus 1 squared plus BM squared. BM equals to the square root of 3 units, therefore BM squared is square root of 3 squared. So 9 equals to A plus 1 squared, and the square root of 3 squared is 3. So from that 9 equals to a plus 1 square plus 3, you will subtract 3 from this equation, and we get that 9 minus 3 is 6, so 6 equals to a plus 1 square. So here we take a root out of this equation, and we will get that the square root of 6 equals to a plus 1. So we subtract 1 from this equation, and we get that a, the missing 9 segment, equals to the square root of 6 minus 1 units. So we can write down in the original drawing that a equals to the square root of 6 minus 1 units. Okay. In the next step, we'll join points A and C together by a straight line. By joining points A and C, we create the triangle ABC. In triangle ABC, this angle ABC equals to 120 degrees because of the fact that it is 1 out of 6 interior angles of the regular hexagon ABCDEF. Therefore, it is equal to 180 degrees because of the fact that all the interior angles of the regular hexagon are equal to each other, and each of them is equal to 120 degrees. Side AB equals to 2 units, and side BC equals to 2 units, because of the fact that all the sides of the regular hexagon, they are the sides of the regular hexagon, and all the sides of this regular hexagon and the sides of any regular hexagon are equal to each other. In this case, all the sides of this regular hexagon, they are equal to 2 units in their lengths. So I'll copy the triangle ABC in the new page, and we'll implement this triangle ABC, the law of cosines. Okay, so maybe before that I will explain to you what is the law of cosines, and then we will implement the law of cosines in this triangle ABC. The law of cosines is true in any triangle. So this is actually triangle ABC, that could be any triangle. And we know that the length of side AB equals to A units, side AC equals to B units in its length, and finally side BC equals to C units in its length. And we also know that the angle between side AB and side AC is theta. Then, according to the law of cosines, C squared, C is the length of side BC, equals to A squared, A is the length of side AB, plus B squared, B is the length of side AC, minus 2 times A times B times cosine theta. Cosine theta is the, actually theta is the angle between side AB and side AC, this angle. So in any triangle, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We can actually implement the law of cosines in triangle ABC. So in the next step, I will copy triangle ABC in this page, and will implement on it the law of cosines. So this is triangle ABC that I covered from the original drawing. Our mission is to find out the length of side AC. So according to the law of cosines, the length of side AC will be equal to, according to the law of cosines, AC square equals to AB square plus CB square minus 2 times AB times CB times cosine 120 degrees. So this equation is the implementation of the law of cosines in our triangle ABC. AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. So AC square equals to AB square. AB equals to 2 units, therefore AB square is 2 squared, that is 4, plus CB square. CB equals to 2, therefore CB square, it is also equals to 4, minus 2 times AB times CB times cosine 20 degrees. So it is minus 2 times AB is 2, CB is also 2, and cosine 120 degrees equals to minus 1R. And minus times minus is plus. So in total this expression will be positive. Okay, so AC square equals to 4 plus 4 and 2 plus 2 is 4, and here 2 over 2 is 1, so those 2 will get cancelled, and in total this expression equals to 4. So I found out that AC square equals to 4 plus 4 plus 4, that is to say AC square equals to 12. Here we'll subtract 12 by 4 times 3, so, and we'll get that AC square equals to 4 times 3. So here we'll take a root out of this equation, and we'll get that AC equals to the square root of 4 times 3. Here we'll take 4 out of the root, the square root of 4 is 2, so in total we'll get that AC equals to 2, and inside the root we left only with 3, so it is 2 times square root of 3. In conclusion, we found out that AC, the length of AC, is equal to 2 times square root of 3 units. So we write down in the original drawing that AC, side AC equals to 2 times square root of 3 units. I'll copy again the right triangle ABC in a new page in order to find out the value of those two angles. You know that this angle ABC equals to 120 degrees, and we have to find out the sizes of those two angles. Okay. Angle ABC equals to 120 degrees. Side AB equals to 2 units. And side BC also equals to 2 units. So actually this is triangle ABC that I copied from the original drawing. Because of the fact that side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. We get that those two angles that are located in front the two equal sides must be also equal to each other. So if we define angle ACB as x, then angle BAC must be also equal to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have x plus 120 degrees. In total they must be equal to 180 degrees. X plus x is 2x plus 120 degrees equals to 180 degrees. If we subtract 120 degrees from this equation, and we get that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. If we divide this equation by 2, and we get that 2x equals to 60 degrees, we divide this equation by 2. So x will be equal to 60 degrees over 2 is 30 degrees. So if I know that this angle x equals to 30 degrees, and this angle is actually x, and it is also angle ACB equals to 30 degrees in its size. So you can write down in the original drawing that this angle ACB equals to 30 degrees. Okay, angle ACB equals to 30 degrees. Okay, so we actually have here angle PCB. This angle PCB, it is equal to 120 degrees in its size because of the fact that it's 1 out of 6 interior angles of this regular hexagon, and all the interior angles of this regular hexagon are equal to each other, and each of them is equal to 120 degrees. So this angle PCB equals to 120 degrees. The small angle ACB equals to 30 degrees on the right side, and therefore the missing angle, that is actually angle PCA, will be equal to the big angle PCB minus the small angle ACB. So I write it down. We have the big angle PCB, so this angle PCB equals to 120 degrees in its size. And we also know that this angle ACB equals to 30 degrees in its size. This is angle ACB that is equal to 30 degrees in its size. and therefore this angle that is actually angle PCA will be equal to the big angle, angle PCB, minus the small angle, angle ACB. The size of angle PCB, the big angle, minus the size of the small angle, angle ACB, will give us the missing angle, angle PCA. So I write it down. Angle, the big angle, angle PCB, that is actually equals to 180 degrees, minus the small angle ACB, that is actually equals to 30 degrees, will give us the missing angle, that is angle PCA. PCA. So the big angle PCB is 120 degrees, the small angle, angle ACB is 30 degrees, and it is equal to the missing angle, that is actually angle PCA. So we actually found out that the missing angle, angle PCA, equals to 120 degrees minus 30 degrees, that is 90 degrees. That is to say, this missing angle, angle PCA, equals to 90 degrees in size. That is to say, it is a missing angle. And because of the fact this angle, angle PCA equals to 90 degrees, therefore, because of the fact that the missing angle PCA equals to 90 degrees, it means the triangle PCA must be a right triangle. Okay? Angle PCA equals to 90 degrees. And therefore triangle PCA is a right triangle. Therefore the green triangle, triangle PCA is a right triangle. So we copy the right green triangle, triangle PCA in a new page, and we'll implement the Pythagoras theorem in this green right triangle, triangle PCA. It is actually triangle PCA, the green triangle, the green right triangle, triangle PCA. So actually this is the right green triangle, triangle PCA, that I copied from the original drawing. Side PC equals to A, it is equal to square root of 6 minus 1 units. Side AC equals to 2 times square root of 3 units. And side AP, it is equal to X according to what is given as the question. So we will implement the Pythagoras theorem in this right triangle, triangle PCA. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in this right triangle is PA, therefore the square of the hypotenuse is PA squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say it must be equal to PC square plus CA square or AC square. PC PA or AP equals to X according to what is given as the question, therefore PA square is X square. That is the line segment that we are looking for, which is equal to PC square. PC is equal to the square root of 6 minus 1, therefore PC square is square root of 6 minus 1 square plus AC square. AC equals to 2 times square root of 3, therefore AC square is 2 times square root of 3 square. In conclusion, we found out that in the right triangle PCA, according to the Pythagoras theorem, x square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. So we have the expression square root of 6 minus 1 square. In order to find out the value of this expression, we will use the algebraic identity that states that A minus B square equals to A square plus B square minus 2 times AB. Okay. In our specific expression, A equals to the square root of 6 units and B equals to 1. And therefore, according to this algebraic identity, minus B square equals to A square plus B square minus 2AB, we get that square root of 6 minus 1 square equals to A square. A is square root of 6, therefore A square is square root of 6 square, that is 6, plus B square. B is 1, so B square is 1 square, that is 1. Minus 2 times A times B. So it is minus 2 times A is square root of 6 and B is 1 times 1. So if we're going to find out that this expression equals to 6 plus 1 minus 2 times square root of 6. Now we will substitute square root of 6 minus 1 square in this equation by 6 plus 1 minus 2 times square root of 6. So, and we get that x square equals to the square root of 6 minus 1 square, and the square root of 6 minus 1 square equals to 6 plus 1 minus 2 times square root of 6 plus 2 times square root of 3 square plus 2 times square root of 3 square. So actually x square equals to 6 plus 1 is 7 minus 2 times square root of 6 and 2 times square root of 3 square is 2 squared, that is 4 times square root of 3 squared, that is 3. 4 times 3 is 12. In conclusion, we found out that x square equals to 7 plus 12 minus 2 times square root of 6. So x square equals to 7 plus 12 is 19 minus 2 times square root of 6. Here we take a root out of this equation and we get that finally x, the line segment that we are looking for, or x, equals to the square root of 19 minus 2 times square root of 6 units. And in terms of numbers, x equals to 3.755 units. Repeat again, the length of line segment AB that is equal to x, it is equal to either the square root of 19 minus 2 times square root of 6 units, so in terms of numbers, x equals to 3.755 units. Okay, so we finish with this question. In the next step, we will summarize the lecture. hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. And we know that one side of this regular hexagon AB equals to 2 units, therefore all the other sides must be also equal to 2 units. And we also know that all those 6 interior angles of this regular hexagon are equal to each other. And in addition, we know that side PB or line segment PB equals to 3 units in its length. And our mission is to find out the length of line segment PA that is equal to x. Okay, so in the first step, we find out the sum of the interior angles in this regular hexagon or in any regular hexagon. Here A, B, C, D, E, F. This is a regular hexagon that could be any regular hexagon. So we find out the sum of the angles in this regular hexagon. In order to find out the sum of the angles, we will join points B and E by a straight line. By joining points B and E, we created here two quadrilaterals. Quadrilateral AB, FE, this quadrilateral, and quadrilateral BC, ED. We know that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the sum of the angles in quadrilateral ABF is equal to 360 degrees, and the sum of the angles in this quadrilateral BCED is also equal to 360 degrees. And it is obvious that the sum of the angles in those two quadrilaterals will be equal to the sum of the angles in this regular hexagon, because of the fact that this regular hexagon consists of those two, exactly, it consists of those two quadrilaterals. Therefore, the sum of the angles in those two quadrilaterals is 360 degrees plus 360 degrees, this is 720 degrees, and this is actually exactly the sum of the angles in this regular hexagon that could be any regular hexagon. Therefore, we actually found out that the sum of the angles in any regular hexagon is equal to 720 degrees. Okay? And because of the fact that any regular hexagon has 6 equal interior angles, 2, 4, 6, in order to find out the size of one angle, one interior angles, in this in any regular hexagon, we will divide the sum of the total angles, that is actually 720 degrees, over the number of the angles, that is 6, and this will give us the size of one angle. So 720 degrees over 6 is 120 degrees, therefore the size of each angle in this regular hexagon and in any other regular hexagon equals to 120 degrees. Okay, so therefore we actually can write down that all those 6 interior angles in this regular hexagon A, B, C, D, E, F are equal to each other, and each of them is equal to 120 degrees in its size. Likewise, because of the fact that all the sides in any regular hexagon are equal to each other and one side equals to 2 units, therefore all the other sides of this regular hexagon will be also equal to 2 units. Okay, in the next step, we extended side DC, this side DC, by a straight line. DC is one side of this regular hexagon, therefore it is absolutely a straight line. And when we extended the straight line DC by a straight line, the result must be a straight line, therefore DL is a straight line. Here, DL is a straight line. Okay? And we also know that the sum of the angles on one side of a straight line is equal to 180 degrees according to the old rule number 1. So if we focus on this side, the left side of the regular hexagon, of the straight line DL, at point C. Here, according to rule number 1, the sum of the angles must be equal to 180 degrees. So which angles we have at this side of DL at point C? We have this angle that is equal to 90 degrees plus the missing angle BCL. So according to rule number 1, 120 degrees plus the missing angle BCL must be equal to 180 degrees. We subtract 120 degrees from this equation and we get that the missing angle BCL equals to 180 degrees minus 120 degrees, it is 60 degrees. This missing angle BCL equals to 60 degrees. Then from point B we draw perpendicular on DL. This is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. In this way we created the right triangle, triangle BCM. I copy the right triangle BCM in a new page and we analyze this right triangle, triangle BCM. This is the right triangle, triangle BCM that I copied from the original drawing. This angle equals to 60 degrees according to rule number 1 and this angle equals to 90 degrees according to our construction. BC is one side out of the 6 sides of the regular hexagon and therefore it is equal to 2 units. Okay, so BC equals to 2 units. In this right triangle, triangle BCM, cosine 60 degrees equals to CM over CB. Okay, CM is the missing 9 segments, so we leave it as it is. BC equals to 2, so we substitute BC by 2. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and 1/2 equals to CM over 2. Here we multiply this equation by 2 and we found out that the missing 9 segment of the missing side CM equals to 1 unit. Here we can write down that CM equals to 1 unit. Likewise, we know that sine of 60 degrees in the right triangle BCM equals to BM over CB. The sine of 60 degrees equals to BM over CB. Sine of 60 degrees is square root of 3 over 2. We substitute sine of 60 degrees by square root of 3 over 2. And it is equal to MB. MB is the missing 9 segments, so we leave it as it is. And CB equals to 2, so we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to MB over 2. We multiply this equation by 2 and we found out that the missing size BM or MB, it is equal to the square root of 3 units. Here BM equals to the square root of 3 units and here also BM equals to the square root of 3 units. In the next step, we joined points A and C together by a straight line. By joining points A and C, in the next step, we focused on the right triangle, triangle PCB. This is the right triangle PCB. Side PC is unknown, so we define side PC as A and CM equals to 1. Therefore, PM equals to A plus 1. BM equals to the square root of 3 units and PB equals to 3 units. So this is the right triangle BM that I copied from the original drawing. The hypotenuse PB equals to 3 units according to what is given us the equation. BM equals to square root of 3 units and PM equals to A plus 1. We implemented here the Pythagoras theorem. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM square plus BM square. So PB square equals to PM square plus BM square according to the Pythagoras theorem. PB equals to 3, therefore PB square is 3 squared, that is 9. And it is equal to PM square. PA is A plus 1, therefore PM is A plus 1, therefore PM square is A plus 1 square plus BM square. BM is equal to 3, therefore BM square is equal to 3 square. So found out that 9 equals to A plus 1 square plus square root of 3 square. So 9 equals to A plus 1 square and the square root of 3 square is 3. Here we subtracted 3 from this equation. 9 minus 3 is 6. Therefore we got that 6 equals to a plus 1 square. If we took a root out of this equation, we found out that the square root of 6 equals to a plus 1. The square root of 6 equals to a plus 1. Here we subtracted 1 from this equation and we found out that a equals to the square root of 6 minus 1 units. So we can write down in the original drawing that 97 PC, the AC 97 PC equals to A, and A equals to the square root of 6 minus 1 units. In the next step, we joined points A and C together by step 9, and this will create a triangle ABC, and we implemented the law of cosines in this triangle, triangle ABC. I reminded you what is the law of cosines. The law of cosines is true in any triangle. So if we have this triangle ABC, this could be any triangle. The length of AB is A units, side AC equals to B units in length, side BC equals to C units in length. Then according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine theta. Theta is the angle between side AB and side AC. We can implement the new the law of cosines in our triangle ABC. So I copy the triangle ABC in this new page. Angle ABC equals to 120 degrees. It is why? Because it is 1 out of the 6 interior angles of the real hexagon A, B, C, D, E, F. Therefore it is equal to 120 degrees. Side AB equals to side BC equals to 2 units. Both sides are equal to 2 units because they are the sides of the regular hexagon, and we know that all the sides of the regular hexagon are equal to each other. Each of them is equal to 2 units. So we implemented the law of cosines in this triangle, triangle ABC. According to the law of cosines, AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. Okay? So AC square equals to AB square. AB is 2, therefore AB square is 2 squared, that is 2, plus BC square. BC is 2, therefore BC square is 2 squared, that is 4, minus 2 times A is 2, and BC is 2, so it is minus 2 times 2, and cosine 120 degrees is minus 1 half. So we substitute cosine 120 degrees by minus 1 half. Okay? So this expression, we have minus times minus, that is plus. So in total this expression will be a positive number. In this positive number we have 2 times 2, that is 4, and 2 over 2 is 1, so those 2 will be cancelled. We get cancelled and we left only with 4. So in conclusion we found out that AC square equals to 4 plus 4 plus 4 plus 4 plus 4 plus 4 is 12, so AC square equals to 12. We substitute 12 by 4 times 3, so AC square equals to 4 times 3. We took out of this equation and we found out that AC equals to the square root of 4 times 3. We took 4 out of the root, the square root of 4 is 2. So AC equals to 2, and inside the root we left only with 3. In conclusion, we found out that the length of this side AC is 2 times square root of 3. So we can write down in the original drawing that AC equals to 2 times square root of 3. Then I copied the right triangle ABC in the new page in order to find out the sizes of those 2 missing angles. This is triangle ABC that I copied from the original drawing. Side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those 2 equal sides we have those 2 equal angles. So if this angle is x, then this angle must be also equal to x. And we know that the sum of the angles in any triangle is equal to 180 degrees, therefore the sum of the angles in triangle ABC must be equal to 180 degrees. So which angles we have here? We have x plus 120 degrees, it must be equal to 180 degrees. So x plus x is 2x, so 2x plus 120 degrees equals to 180 degrees. We subtracted 120 degrees from this equation and found out that 180 degrees minus 120 degrees is 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2 and found out finally that x equals to 60 over 2 is 30 degrees. So this angle equals to 30 degrees and this angle x equals to 30 degrees. So angle ACB equals to 30 degrees. We can write down in the original drawing that this angle ACB equals to 30 degrees. So we have the big angle PCB that is 120 degrees. We have the small angle ACB that is 30 degrees. Therefore, the missing angle PCA will be equal to the big angle PCB minus the small angle ACB. That will be equal to the missing angle PCA. Repeating again, we have the big angle ACB that is equal to 120 degrees. We have the small angle ACB that is equal to 30 degrees. Therefore, the missing angle PCA equals to the big angle PCB minus the small angle that is ACB. That is the value of the missing angle PCA. So PCB is 120 degrees, ACB is 30 degrees. Therefore, the missing angle PCA equals to 120 degrees minus 40 degrees, that is 90 degrees. So we found out that the missing angle PCA equals to 90 degrees, that is to say it is a right angle. And because of the fact that it is a right angle, therefore triangle PCA is a right triangle. So this is triangle PCA, and this green triangle PCA, it is a right angle because this angle PCA equals to 90 degrees. So I copied the right triangle PCA in a new page and implemented in this right green triangle PCA the Pythagoras theorem. According to the Pythagoras theorem, here this is the right angle PCA. Angle PCA equals to 90 degrees. PC equals to A equals to the square root of 6 minus 1 units. AC equals to 2 times square root of 3 units, and AP equals to X according to what is given as the question. We implemented it, the Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in triangle PCA is AP, and therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. AP or PA is X, therefore PA squared is X squared. PC is square root of 6 minus 1 units, therefore PC squared is square root of 6 minus 1 squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. Okay, so according to the Pythagoras theorem, we found out that X squared equals to the square root of 6 minus 1 squared plus 2 times square root of 3 squared. We found out the value of this expression, square root of 6 minus 1 squared, according to the algebraic identity, that A minus B squared equals to A squared plus B squared minus 2 times AB. In our specific expression, A equals to the square root of 6 and B equals to 1. And therefore, according to this trigonometric identity, the value of square root of 6 minus 1 squared will be equal to A squared. A is square root of 6, therefore A squared is square root of 6 squared, that is 6, plus B squared. B is 1, therefore B squared is 1 squared, that is also 1, minus 2 times A is square root of 6, and B is 1. So, in conclusion, we found out that the value of this expression, square root of 6 minus 1 squared, according to this algebraic identity, equals to 6 plus 1 minus 2 times square root of 6. Therefore, we can substitute square root of 6 minus 1 in this equation by 6 plus 1 minus 2 times square root of B. So, we did it, and we got that X squared equals to 6 plus 1 minus 2 times square root of 6 plus 2 times square root of 3 squared. So X squared equals to 6 plus 1 is 7 minus 2 times square root of 6, and square root 2 times square root of 3 squared. It is actually 2 squared, that is 4, times square root of 3 squared is 3, and 4 times 3 is 12. In conclusion, we found out that X squared equals to 7 minus 2 times square root of 6 plus 12. 7 plus 12 is 19, and therefore we found out that X squared equals to 19 minus 2 times square root of 6. Here we took out of this equation, and we found out that X equals to the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, X equals to 3.755 units. I'll repeat again, that the length of side AP is equal to X, it is equal to either square root of 19 minus 2 times square root of 6 units, or in terms of numbers, AP is equal to X, it is equal to 3.755 units. Okay, thank you very much.